Thanks for coming to Observability, building a bridge from software development to software ownership. Today I'll be talking about how observability, a word that's traditionally associated with monitoring, with over there in production land, is a mindset and a set of tools that can benefit us not just after, but before and during our software development process. I'm also a co-founder at Honeycomb, which is focused on empowering engineering teams to understand their software in production. I'll be sharing some examples about how we dog food in order to deliver the best software experience we can to our Honeycomb customers. First, who am I? Well, I'm Christine, and I'm a developer who delights in being a room full of ops folks. And because I'm building a product focused on helping all engineers understand their production systems, I care a lot about bridging the gap between dev and ops with technological and cultural improvements. These days, software development is usually super customer focused. There's a whole suite of stuff we're really diligent about. Before we ship, at which point we celebrate. And then, more often than not, we sort of just let things sit and we forget about them until someone tells us that our software is broken. From the developer's perspective, though, we can use data about how our code is being run in production to really explore what our services are doing. And as a result, we can inform not only what features we build or bugs we fix, but how to build them, how to scope them in order to figure out which use cases are important to cover or can be safely ignored, how to verify correctness and completion, and how to roll that feature or bug fix out, and how to make sure that we're doing it as carefully as possible and that the work that we're rolling out is able to provide the experience that we expect it to our customers. And the reason using data to explore and asking questions about how our code is behaving is important is that during the development process, we've got a lot of questions about our system that don't smell like traditional production monitoring questions, but should absolutely rely on production data to answer them. Because not all interesting things are problems. They often don't show up in our dashboards because what was interesting last week or 2 weeks ago when we set up 2 months ago when we set up that dashboard might not be what's interesting or relevant to my development today. Almost certainly won't show up in our exception trackers unless it's exceptional, but lots of things are interesting that aren't necessarily exception throwing, which leaves us to go seek out these interesting bits of knowledge. Because the interesting things about my code are the hypotheticals about what does normal even mean, or does theory match reality in how my code is behaving? And I really like the word observability for capturing this sort of curiosity, where observability is all about really being able to understand what a system is doing based on observing it from the outside, based on the data, the logs or events it's throwing off, almost like the data exhaust. And this is a different word than the traditional monitoring because it's a different mindset and approach to how we think about our systems. Instead of trying to predict all the different ways that things might go wrong, instead of trying to define our system as a well-understood system and then establishing thresholds, instead we're acknowledging that the system is a living thing, is something that is evolving over time, and a system that is dealing with a kind of an ever-increasing explosion of complexity, which means that we, as the developers and maintainers of the software, have to be able to stick our hands in and ask new questions to find out why is it behaving this, strangely today? What happened in the last week that means that this thing that used to be stable isn't stable anymore? Because today, there's too much code now in production for developers to not take ownership of what gets deployed. There's too many moving pieces for what happens in production to be purely ops' problem. If the first wave of DevOps was all about teaching ops people to code and automate their workflows, the second wave is going to have to be about teaching developers to get comfortable owning their code in production. And the SRE movement really fits in here as well. Investing in observability, teaching developers to look at production, to think about how their code is going to behave, to think about what signals are going to indicate that their code is behaving as expected or not, is what is going to enable our software developers to go from, oh, well, this works on my machine, to I know that this is going to continue working in production and I will be able to take ownership of this service. So observability must be a core part of the development process as the software is being built, not just when it's being evaluated for reliability or right before it's deployed. We really need to be feeding useful information into each step of this process. As much as testing or documentation, understanding what our code does in production teaches us to build better software all the time. Because observability isn't just for finding out when things are broken or going wrong. It's for understanding your software and understanding what's normal so that you can continue to deliver a great experience. So let's go back to the slide of all the things that developers do, break them down into some more manageable steps. First, we're figuring out what to build, what to spend our time on, if there is a problem or something going wrong that we need to address. Then we need to actually do the work, get our hands dirty, write the code, make sure that our plans are going to be feasible. Then we write tests to make sure that it works on my machine. This is the local CI, almost pre-CI/CD stage. And then once it's deployed, we need to make sure that the code continues working, right? Sanity check. Code's live. Does it do what I expected it to do? And finally, we have to make sure that it keeps working. Over time, even when I'm asleep, is my code continuing to do what I expect? Now these first three, before the code hits production, what informs each of these? Is it just our fantastic developer intuition? Do we have a PM feeding us instructions? I mean, the answer to those both might be yes, but I sure hope we have some real data coming in as well. Let's take a look at some real-world examples of what using data in each of these stages of the development process might look like. First step, debugging. And debugging here is used in the context of, let's figure out whether something unexpected is happening and why it might be happening. When we're debugging things locally, you have things like log lines and printfs, maybe you have a debugger attached to your IDE. But in production, there are certain things that can only be debugged or diagnosed in production at scale. Sidebar, this ideal case, in the ideal case in production, when we have all the information about what happened and when and for whom, we essentially have the ability to replay the past. As a caveat, since most of us won't start in the ideal case, our tools should also make it easy to add new pieces of metadata when we need it. So Honeycomb is, at its core, something that you send data into and then query back out in real time. And we pride ourselves on basically a 1 second delay under a 1 second delay between hitting our API server and being available for querying. And so when we have a customer coming to us saying, my data isn't showing up, this is a problem. It's something very much worth investigating, and it's something worth going, hey, are you sure? One of the things that we added along the way, speaking of making it easy to add new metadata to explore hypotheses, was a field called event time delta sec. This was something that we added in order to capture the difference in the number of seconds between the time it hit our API and the timestamp associated with the event. Where the timestamp associated with the event is presumably when the customer captured that event in order for it to be sent to Honeycomb. Okay, let's take a look at what that might tell us. This is our dog food cluster. Shepherd is our codename for our API server. And what folks might care about is, okay, someone's complaining that their data's not showing up. Weird. Let's figure out why. First I'm going to pull up a heat map of event time delta sec over the last 10 minutes just to see what is the normal range of times here. What is the normal distribution of people sending in these events, and are they all getting delayed, or is there kind of a small subset of them getting delayed? So here we can see that most events are coming in, under a fairly tight window of delay. They're coming in fairly close to, they're being captured fairly close to when they're hitting our API. But there is this streak up here of events that seem to have a fairly high delay between when the event was captured and when it was sent to Honeycomb. One of the interactions we've always wanted to be able to support in Honeycomb is being able to say, well, this artifact on a graph is weird. Why is that? And with something that we call bubble up, you can. What we can do is we can actually select the section on this heat map to say, tell me what's different about the requests, the events that are coming in to our API server that end up inside this selection versus the ones that end up outside the selection. So if we scroll down, remembering that our selection is the yellow area, we can find out that, well, all right, they're sending JSON in of a particular structure. But more interestingly, there's one specific data set that's doing that. One specific data set on one particular team. Interesting. I wonder if this is affecting all of that team's data sets, or if they're only sending one data set in, and or if this is only impacting one of their data sets. So I can very easily immediately jump in and zoom into one particular team. I can break down, I can get the same distribution of emitting to ingest delay, but I can break down by dataset ID to find out, hey, how many datasets are we actively ingesting from them at the same time? And is this delay impacting all their datasets or only one? And we can see they're sending in 3 datasets. It is in fact only impacting one of their datasets. Being able to look at production, debug, and really understand what we're seeing, what the customer is experiencing, lets us be a lot more thoughtful about going back to the customer and saying, hey, yeah, you're right, your data's not showing up. We know why. It's happening to only this one data set, and it's happening to, maybe here are some steps to potentially remediate the situation. And this allows us to, as engineers supporting this application, be a lot more authoritative and helpful to improve the user's end experience. And it helps us understand how often users end up in this situation. So, okay, that was identifying what we needed to do. How do we know what the right way to build something is? Because there's a difference between knowing that something should be changed or built and knowing how it should be. Understanding the potential impact of a change that we're making, especially something that will have a direct, obvious impact on its users, really gives us an opportunity to bring data in to the decision-making process from production. By learning about what normal is, or at least what reality is, we can figure out whether our fix is actually a fix or not. And I love this section because it turns the events that our software is emitting almost into debug statements in our production traffic that we can use. If we have a local branch or an experimental branch that we want to test with an initial solution. A couple of our customers will test out example algorithms implementing a particular goal and see which one behaves the best before actually flipping a switch and using the output of those algorithms to change the user experience. By having a flow where it's lightweight and natural for software engineers to add these little diagnostic bits and suddenly be able to describe the execution of your logic in the wild, we can make more informed decisions and deliver better experiences to our customers. And so while product managers may make decisions based on grand intuition and many, many product qualitative interviews, we're developers. We have access to production data, and we can make arguments based on what we are measuring and seeing in reality. So the demo I'm going to show here is one that takes performance analysis into account. Let's say we'll be looking at our query engine, and we can say, let's say that we are currently undergoing a performance initiative to understand how to optimize certain parts of our query engine's work. I'm going to ship just data sets. Retriever traces is our tracing data set. It contains a lot of information about what happens each time someone hits run query in production. And over here, I can find past queries that I've run. More interestingly, since I may not be as familiar with this data set, I can see some of the queries that my teammates have run. This is an overall heat map showing the distribution of latencies of all the individual, essentially, functions that are being run over the course of a query execution. And while this is nice, what I'm actually interested in is I want to zoom in into a particular type of work that we've been working on optimizing. So I happen to know that the function is named merge lambda segment. And in addition to the distribution of latencies, I'm actually going to capture the sum, because I want to know a little bit more about where we are spending the most total time. What sorts of queries accumulate the most time spent in this particular function? And so, okay, narrowed down to this particular function, we get a little bit more visibility into the distributions of latencies over time. And let's say I actually want to go one step deeper. I want to find the traces that are spending the most time in this function. Now I've got a long table down here of all the traces in this time range, or I can actually just jump in and click straight from the graph. So let's say I'm going to click into this. Why are we spending 450 milliseconds cumulative in this function? And so what we can see now is if we look for our merge lambda segment spans, we can see a much clearer representation of how we're spending our time, where we're spending our time with all this metadata over here on the right, and really start to dig into where we can optimize and find opportunities for performance optimization. Okay, so that was tracing, that was understanding how to achieve this goal that we've set out for ourselves. Now, testing. So testing is an important part of the software development process. But how do we select our test cases? A lot of the time, the answer here, again, tends to be intuition or guessing at edge cases that matter. But why not use production data to understand which test cases are worthwhile? Pretty nice to be able to go and actually look at our production data to say, hey, of all the payloads hitting our API, we're going back to the API dataset, what is the distribution of the number of columns in each payload? And I can capture the min, the max, and again, for visualization's sake, let's capture that over the last min, the max, and the heat map, showing the overall distribution. And now I have some pretty solid numbers I can toss in to my test cases. I can use to reflect what our systems really experience in production. And I can even go back and find older versions of this graph on older data to find out what outliers were back then. A note. This right here, this difference between what we're seeing right now in the last 2 hours, around a max of 100, 200, versus some point in the past we had someone sending 500 columns per payload. This is why humans defining test cases is never going to be quite enough. Because even though we're using data in the wild to inform what test cases to define today, what crazy what our outliers are, what our edge cases are that we'll need to cover. Who knows what crazy things will happen next month, next week, next year. Okay, we've tested on our machine, we've got our CI/CD pipeline set up. What happens when all of those tests pass and we're still not quite sure about our change, and we want to roll that change out carefully and check its impact in some lightweight or temporary way? Because ultimately, there are some things that you can only test in a production environment, at real scale, on a real network, over real data. Complex systems today have an almost infinitely long list of nearly impossible failure scenarios, but as they get more complex, as we add more components and more dependencies, the number of potentially dangerous interactions only increases. And the importance of being able to handle those or anticipate some of those highly rare, extremely unpredictable black swan failure scenarios increases. But we can't predict them all, right? There's just too many of them. What we do need to do is make sure that if something happens, we find out immediately and have enough information to know what to do about it. Testing before and after you deploy something to production are complementary actions and are both absolutely necessary. When you know the answer to what happens when we have this kind of input, you can write a test for it, and you should. You should crystallize that and preserve it so that it prevents regressions. But when you don't know the answer to it yet, when you just have a hypothesis and you need to see what actually happens in production, you should experiment and learn what you can under controlled conditions. So, speaking of our favorite way to test out a hypothesis, we love feature flags for letting us test in production while we're still making sure that the change is one that we're happy with shipping. Pairing feature flags with our observability tooling lets us get incredibly fine-grained visibility into our code's impact. Being able to get these arbitrary feature flags into our dog food cluster means that we can look at our normal top-level metrics, but segmented by these arbitrary flags. And this becomes incredibly powerful when we can do things like test code out onto a very small amount of traffic determined by the logic behind the feature flag, while still retaining the ability to slice by host name or customer or shopping cart, whatever matters most to my business. And the best part about this approach means that your developers can define these ephemeral, very specific segments of your data freely in order to answer the sorts of ephemeral, specific questions that tend to pop up during development. So at this point in our development cycle, we actually send all live feature flags and their values along with all payloads to our storage engine dataset, so that as we observe future experiments, we don't have to stop first and remember to add the feature flag to a metric name or dashboard. They're all just right there, mapped to the flags that we as software engineers are already thinking about. This is a story from a couple years ago when we were still making a number of changes to our storage layer, and changes to our storage layer in our query engine are hard to test locally, both because of scale and because of the diversity of the types of data that hit that storage engine. A while back, we were making changes to our string storage format. It was a change that was intended to make things more flexible. We were fairly confident in its correctness, but we wanted to make sure that it wouldn't impact performance significantly. And yes, we had performance tests and benchmarks set up in our code. But again, we knew that the real variety was going to be in production. So we wanted to roll it out very carefully, one dataset at a time. This would let us, being able to control that through feature flags, would give us greater isolation and the ability to compare the performance impact in a more fine-grained way than if we'd done it, say, one storage host at a time. So with our feature flag setup, we could go from our top-level metrics around overall write volumes and average latency of each batch of writes, to being able to really inspect the count and average for datasets in the experiment versus the metrics for datasets not in the experiment. So in the top graph, that graph's purple line shows writes that have been flagged into the new code. You can see just at that little marker that we dropped when we changed the value of that flag, a whole bunch more writes suddenly were flagged into the new code. And the bottom graph shows the impact of that flagged code on our storage engine's write latency. So we could see, oh gosh, I guess we did make a change. And something else we could do is, along with being able to slice by whether the flag was set or not, We could even come up with our own arbitrary definitions for other things that we wanted to slice by in order to really dig into and try to understand the impact of the flag in combination with other features of that traffic. All right, watching our code after it's been deployed. This stage everyone's familiar with, right? We monitor production by staring at dashboards, scrolling through dashboards, and really hoping that the dashboards from a month ago, 6 months ago, a year ago, reflect the problems that we're experiencing today. And I want to press on this especially because it's a great example of tools that reinforce that ops-dev split I touched on earlier. What's the biggest source of chaos in our systems? Usually humans, software engineers, us pushing new code. And our tools have to be able to reflect this chaos accurately. And the better they do, the better we, software engineers, will be able to understand what impact our code has on production. So when I think about this watching step, first, it's all about watching to make sure that reality lines up with expectations. The same way that you do when you write a test that you want to reinforce with CI, you really want to make sure that, hey, in production, I expect this thing to happen. Let's make sure it's actually happening. But doing it in the terms that we, software developers, understand intimately. Monitoring traditionally, when I think about traditional monitoring, I think of CPU graphs and memory graphs, disk usage. And if an ops person comes to me and tells me that CPU is up on our API servers, I can't immediately act on that. I might have an abstract idea of how to translate that into a fix in the code, but those aren't the terms that I work with day to day. Those aren't the terms that I know how my code influences. What I would understand and be able to immediately act on is an ops person coming to me, or ideally me discovering myself, that the latest deploy has significantly increased latency on one particular endpoint for our biggest customer. Great. Now I understand where and when to find that possible source of that change in performance. Let's take another look at what this might look like. Stepping away from our API for a second, we're going to look at our web app. Our web app is called Poodle. And what I love is that our engineers have actually captured this query as one of the starter queries in the dataset. It's so useful to know, hey, I just shipped this feature. I think it just merged to master. It should have deployed recently. Is it in prod yet? Because there's nothing more frustrating than having it, sitting, watching your thing get merged to production or merged into master, and sitting there refreshing, wondering why a browser hasn't shown you the changes that you expect yet. But here we can see, right, it's not just a point in time that my code has been pushed to production. Over this 15-minute period, we're doing a rolling restart, and we can actually see the number of servers serving this code decrease while our new code gets rolled out. And again, this query not only tells me the volume of requests coming through our web app, but also, hey, is it impacting the number of errors being thrown? And you can imagine this sort of query, this sort of really granular breakdown going into, hey, was it my build? Was it the build that contained my change that caused this latency spike, or was it someone else's? How do we know which thing to roll back? Well, we've pinpointed it. We can attribute it to the build right here. It feels like table stakes, right? It feels like these are things that we should always know about production, but often they're not. And so this whole movement from developers to software ownership means that we can't just be thinking about observability, about production, about what happens after we hit merge at the end of the process. We have to be thinking about this at each stage of the development process. And we need to be looking to production to keep us grounded with what's normal, what's really happening. By capturing more lightweight, transient, native to developers information in prod, even before we flip a switch and ship the real code, we'll be better informed, make better choices, and deliver better experiences for our users. Observability should be a core part of how we understand what to build, how to build it, and who we're building it for. By testing before production and then testing again in production via observability, we'll be able to ask the questions that let us make sure we're on the right track and spending our time on the things that matter. Because we have the power to use data to be better developers and ship better software. Thanks.